How to debug Linux kernel panics and crashes. Imagine your computer suddenly stops working and displays a cryptic message. That's a Linux kernel panic or crash, and it can be caused by many issues. Today, we're going to look at how to find out what went wrong and fix it. First, understanding what a kernel panic is helps. It's a critical failure in the core part of Linux that stops the system from running safely. An oops is a less severe error where the kernel notices something odd but tries to keep going. Both produce messages that point to the problem area. The simplest way to start debugging is by using printk. Think of printk as the kernel's version of print in regular programming. You add these statements in the kernel code to output messages to the kernel log. These messages show the flow of execution and help you see where the panic happens. When a panic occurs, the kernel prints a crash message. This message includes details like error type, memory addresses, register states, and a stack trace. The stack trace is especially helpful because it shows the sequence of function calls leading up to the crash. By analyzing it, you can identify the exact function and line of code causing the problem. To analyze crashes after they happen, Linux offers crash dump tools like kdump. Kdump captures the system memory at the moment of failure. It works with kexec, which boots into a second kernel to collect this dump without fully restarting the system. Once you have the dump, you can examine it with tools like crash or kgdb, which help you inspect the kernel state and find the root cause. Using kgdb with the unstripped kernel image that contains debug symbols allows you to match crash addresses to specific source code lines. Commands like list in kgdb show you the exact code where the problem occurred. This makes debugging more precise. For live debugging, kgdb is very useful. It connects a debugger to a running kernel through serial or network connections. With kgdb, you can set breakpoints, step through code, and check variables in real time. This is especially helpful for bugs that are hard to reproduce. The Linux kernel also has debugging options for memory leaks, race conditions, and deadlocks. These tools help identify issues that could lead to panics. They give you extra clues about what might be causing instability. While core techniques are similar across Linux distributions, some tools and configurations may vary. Make sure your distribution supports crash dump setup, debug kernels, and symbol packages. Installing these tools and enabling debugging options is essential for effective troubleshooting. In summary, debugging Linux kernel panics involves checking logs with printk, analyzing crash messages and stack traces, capturing crash dumps with kdump, and using kgdb or kgdb for detailed inspection. Using these methods, you can find the cause of system crashes and work towards fixing them. This process helps keep your Linux system stable and reliable.